All right, so here's part two of the game save information. Wanted to go ahead and show you guys some old code that we had here for Starcatcher to give you guys an example of what's going on. So just want to preface this with some information. So the nice part about C Sharp is that it has the ability to go down to the base language of the machine. So compare that to Java, which is technically a virtual machine running on top of your computer, which can slow down performance. Because more recent versions of Java are a little bit more efficient with this, and this doesn't apply as much. But still, it's a computer running on top of your computer, so it can slow down performance. C Sharp, instead, what it does is it compiles down to the native language, which has some benefits to performance. It does have some downsides. If the language doesn't contain the ability to do something that you want to do, it's not going to be an option for any of the or at all in the framework that you're using. And for Unity's case, that means it has to be available on all of the devices at once because you're going to be cross-platform developing. So if you don't know how to make things yourself, or if you need access to something that you don't have access to, that is one of the downsides that you can face in C Sharp. Probably the best language that you can if you're looking for both performance and the ability is C and C++. The downside is it will take a lot longer and you're going to be a little bit harder to port things over because each operating system has its own version of C and C++, which operates technically a little bit differently. So with that out of the way, let's go ahead and get down into it. So the game save file right here, this goes over everything from part one. So in part one, I mentioned you need to find everything that you want to save and you want to record it. I'm going to go through this pretty briefly right here. Just talk about the basics in it, and then how I took part one and applied it to this section. And I've basically just made a class where I can save all this information, and I can save it and load it from the game save info class. So the first thing that I do is I say, hey, I need the player position and I need the current scene, right? I need to know what scene I was in and what position my character was in so I can load the information correctly. So let's go ahead and get down into it. So the player position, it's a list of key value pairs. So this contains a string, which is the scene name, and then a float, which is a float array, as you can see down here, what was highlighted, of 3, which contains the X, Y, and Z coordinates for my player. So that way I can say, hey, this is the scene I'm in, this is the position that I'm in, and I can save that information for every scene. So even if I walk through a door, go to another scene, and then walk back and go back to the old scene, I'll know exactly where I was. So this is important in-game as well as when you eventually have to quit the game and need to save your information. I also need to make sure I know which the current scene that I was in, so when I load the game, I'm in the right scene. As far as the game name goes, this is important to keep separate. In my instance, for this version, I actually use the player's name as the game save name, just to make it simple. But you want to keep it separate in case maybe you want to do a different naming schema, you want to change things, but you don't want to change the player's name. So I have the game name right there. Down below it, I have my two variable types. I have variables and I have integer variables. For the one I use more frequently, I actually have a hash table, which I mentioned to you guys before is a very powerful machine. It allows for me to basically store information and record or pull information extremely fast. I can't really organize the list super fast, but I'm not interested in organizing it. I'm just interested in saving and checking to see if it's there. And for how I implemented this is basically, let's just say the variables, and then I'll give an example of the integer variables. The variables say we have a rock that needs to be removed if the player has a certain item. Then when I load the game, I want to make sure that rock's still removed, right? So I just check using the variables. I say, hey, does my game save contain this variable? So dot get variables, right? And then does it contain this variable name? Maybe it's rock1 from scene 2, right? And sure enough, if it does, then I can unload it. If it returns false, then I can say, hey, well, make sure that it loads on the game's, the scene's loading sequence. So that's how I use the variables, and that's why it's important for me for it to be a hash table so that's extremely fast so that your loading is faster when you go from scene to scene. Integer variables, I don't use as frequently. It's going to be a smaller list, and so that's why I didn't make it a hash table. I could transition this. I just knew for my personal use that it wasn't going to be needed. So the integer variables that I have right here, this is if I need to record like how many times someone has done something, and it counted up. The next thing that I have right here is I have the player hero. And with player hero, that's where I store the majority of my data. So this is where all of the inventory is. This is where all the other players are. This is where everything is. And that's just because everything is a composite of player. At a different point in time, I can talk about composition and I can talk about inheritance. But for this specific series, I'm not going to get into it too much since that's a completely different topic. One of the big things that I want to note here, though, this is the first custom type that you guys seen in here. It's not a primitive or something built in. So I actually have to add system.serializable to player and then every single class outside of player that player uses. So like weapon, inventory, anything that I have which player calls or can call needs to have system.serializable on the top. That's going to allow us to save, and I'll get more into that a little bit later. The next after that is I have the player sprites and animations. So currently you can't use system.serializable for Unity type items. So something like a runtime controller, a sprite, an image that's specifically from the Unity libraries. So instead what I do is I make an array of strings which contains the location where they're at, because you can use the resources.load from Unity to load resources. That way I can make my sprites and animations dynamic, and you're not stuck with the same character sprite. So that's important for people to understand. If you have more questions on that, just let me know and I can go into more depth. The next thing and last thing that I have down here is a list of NPCs. These are shopkeeps because shopkeeps need to understand how their inventories change. So I record that information using this tab or using this right here. And as you can see for the game save information, I have a constructor here for a new game save. So this takes in, the current position, their scene, and their name, as well as the hero. That way I can go ahead and create a new game save. For loading a game save, I actually just take in an old one, and then I set all the information equal to the information that came in. That way I can handle, I like to deal with copies of things, just because it's a little bit more safe, data safe, instead of just using one thing and having the potential for corruption between it all. And then, as you can see on all these are all private, which means that I need getters and setters. Now, the benefit of getters and setters, if I hover over this area right here, you can see the region where it contains, is I can control how data is pulled. So what data can you pull, how you pull it, and I can also control how you set the data and what data you can modify. So it's a little bit more professional to use this. That way you can control how the data is going to be modified in your system and lock things that you don't want control, or make sure that everything is included, because there's no way that it can technically mess up. So I'd recommend, instead of using public for all these, private, and then use getters and setters. They do take more time, but it is worth it in the long run. Okay, now running over to the save game. So for save game, what I have is, this is actually a unique class. It's a static class. So what static means is I never have to say, you've probably done this before, like making a new player. Say player, new player equals new player. That's how you initialize a class. For save game, since it's static, I do not need to do that. I don't ever have to do that. All I have to do is say save game, dot, and then I can call any of these functions. So the benefit to that is that I can call it from any class without having to create a new instance of it, and I can only have one of each type, which is good. I only want one game save. I don't want to be accidentally juggling around 4 game saves because of my code logic and maybe doing corruption across my game saves. So I can make sure that I only have one current load at a time. I can also make sure that I only have one combat scene and everything else is just one at a time, which is extremely useful. And then the other thing is, since I record the hero in here, I can say, hey, if I have this class that needs to access something in the hero, maybe I need to pull what kind of what NPCs are in this class or what kind of damage they do or whatnot. Instead of having to drag and drop in Unity that object and then pull the class from that object, I can just call my save game. So static classes are really nice. You do have to make sure that everything in here is static. And again, remember, you can only create one instance of it, so you can't have multiple instances. But if you're thinking about having a static, it's really nice. It's similar to a singleton in Java. All right, and then next up, we have the actual save and the loading. So the first thing I'm going to walk you through is I'm going to walk you through the save game. So the save game right here takes in this game save info, which we went over right here, and it will take this information and transform it into an XML or a custom save file of my choice. Now, in this instance, I'm actually going to be using, you can use a different formatter of your choice. Now, binary formatter, basically what this does is it formats the data into the text document that you're going to have. I use a binary formatter, or used a binary formatter, I should say, just to kind of obfuscate the data so that it's harder to read. So you're going to have to initialize the formatter of your choice, initialize it. You can just type in formatters for C# into Bing or Google, whatever your preference is, and you can find out which ones you can use. But this is what takes the system.serializable right here. So I initialize my formatter. I need to make the name for my game save. So I go ahead and I get the name, which again is the player's name for me, and then any dot extension that you want will work. I use specifically game save. Now you can call it whatever you want. It could be .toodles, .gs, whatever you care to do. You just need to be consistent with it. So in my instance, I use .gamesave, and that's what I call my game saves. And then on string path, I go ahead and I find the path where I'm going to save it. So this is important because you can't just type in like, oh, on the C drive on this location, because it's going to be different depending on which operating system you're working on. So in this instance, what I do is we use application, which will pull from C# the locations on the local hard drive specific to that device. And then I'm using specifically the persistent data path. Now, there are different options right here that you can use. In specific, I want to use the persistent data path, though, because if a player gets a brand new phone and they transfer their information to the phone using the Samsung transfer or an iPhone transfer, it's going to stay with the phone because it's the persistent data path. If they have to delete the game, it's going to stay with the phone unless they clear the data and the cache from the app before they delete it. So this is important so that if your players are experiencing issues with the game or need a new phone, they can delete it or get to the new phone and not lose their data. So I specifically chose this due to this reason. And then what I do is I take the file name, which is, let's say the name of the character is Bob, bob.gamesave, and we turn it into a path. So on Windows, this might look something like c.users.thisperson all the way to your app data, and the local path, I believe, not the roaming, the local path, and then it will actually save this file under your location, so Starcatcher in this instance. So next, I need to come in here. I need to take that path and say, hey, is there already something on the computer like this? If not, what we do is we initialize a file stream. And this is important. This is basically Windows, or not Windows, sorry. This is C# saying, hey, I want to go ahead on this file and I want to do something with the data. In this instance, I pass in the path and I'm saying file mode.create. I want to write to the system. So that's what this file mode.create is doing. So I create the new stream and I say this stream, open up the location on this part of the hard drive and allow me to write to it. And if you have the permission, it will allow you to do that. Next thing you need to do is you need to go to game, you need to get your information. Now I actually just make a copy. So in this instance, I'm copying the data right here. So here's my new save, and that way I don't corrupt anything. It's just being a little bit careful. And then I take my formatter, and now I can call, with any formatter that I want, I can call .serialize. That's what the system.serializable does. I can serialize the stream, which is the location where I want to write to, with the information I want to write to it. So here's the game save. So what we'll do is we'll write on this location all that information. And then important right here, you have to close the stream afterwards. Actually, a better way to do this would be to make a try catch where I say, hey, try to do this. And actually, I'd probably throw this outside of the try catch. And then if it doesn't, I can say catch and then stream.close. So I can make sure that I always close my stream no matter what. So that's a little bit more proper. You would want to do that anywhere you have these things. I didn't in this instance. That's been fixed in the future. But yeah, so that makes it so your system doesn't crash. Now, finally, and to finish off this lengthy series, sorry, I just want to go in a lot of depth for you guys, so it will be a little bit longer, this is handling a new save. The only difference between the new save and if it doesn't have a save, for the people that haven't noticed already, is you just delete the old save. So in this instance, I say, hey, delete, get rid of the old save file, and then I come in here and I do the same thing. Now, loading the game is very similar. What I'm going to do is I'm going to say, hey, here's the player's name, the old path. I'm going to make it into the actual path that I need to do, which means I need to find the name. So I add the player's name to .gamesave. Then I do the same thing right here as I did above. I make the path to find the file location on the specific operating system. I say, hey, if it exists, what I want to do, call the formatter again. This time I'm going to treat it a little bit differently. Call the file stream. This instance I say read only, which is file mode.open instead of file mode.create. And now what I'm going to do is I'm going to say, hey, I want to make the game save, old save, I want to actually open this up so I can utilize the save information. And I do formatter.deserialize instead of serialize. So right here I'm serializing the data, and here I'm deserializing. I'm reading it. And since this will technically create a variable or an object in C#, what I can do is I can declare it using the as statement as a game save info. So I say, hey, formatter.deserialize the stream, and then deserialize it specifically as this data type. Now, if it's not the data type, if you did it as a player, for some reason you save the player information, but you try to turn the player information to a game save class, you're going to crash. So a try catch would be important around here if you're doing something stupid or if you have corrupted data. In this instance, I haven't done this in this old version. Again, an old version, I was just testing things out. And then the important thing is you remember, close that stream off. Once you've done reading and writing, close off the stream. That's important for different operating systems to do. You don't want to have open streams and open systems. Otherwise, you won't be able to save or load your data in the future on that specific path. And then in specific, I go ahead and I take that current save and I set it as my static game save information. That way they can only access one game save at a time. So I'm not having corruption, as I talked about before. And same with the hero. That way I can access the hero anywhere I need to. Then I go ahead and say, hey, here's the current scene. And I just do that for my own sanity's sake so I can see what I'm doing. And I return the game save. And the reason why I return this is actually just to say, hey, did it work? If it's a valid game save, then I know it worked. If it's not, if I return a null, say the file does not exist, then I can handle that in the UI and I can tell the players, hey, sorry, it's not there. So this is extremely important if you're handling data because, again, you might have something that gets deleted in transit or whatnot, or maybe it shows up in there but it was deleted and the UI hasn't been refreshed. So you can handle the errors right here. And then a try catch would be important to throw around here. So as you can see, the save game and the load game, very similar. If you need to pause at any time or if you have any questions, go ahead and ask me and I can go ahead and provide those answers or just pause it and take a longer gander at it. To sum up, though, the important things is, with part 1, declare everything you need in here. If you need to add something to this later on, you're going to have invalid corrupted game saves, and that's going to make it so you can't use those saves anymore. And you might want to do that, especially if you have a long game and you don't have a current cheat system to get through it fast. So make sure, as part 1 states, you go through all of the primitives and everything that you need to do, and then you go through all the unity types, and you go through all the custom types, and you handle it, and then all the custom types you need to add system.serializable to. Not just the player. If the player has a weapon, you have to add that as well. So that's important. And then I would, again, highly recommend using getters and setters and making everything private. So that will conclude it for part 2. If you have any questions, please just let me know. I'll be happy to answer them as they pop up. Thanks. Have a great day, and thank you for supporting us.